Hi, this is Chapter 2, Axioms of Probabilities. This video going to preview the three important axioms of probabilities and also going to give you some ideas of the important propositions. So let's look at the definition first. Let P be a function that assigns a non-negative real number to each event B of a sample space S. Notice the notation. It will have to be non-negative real number. This is going to be linked to one of the axioms that we're going to see in a minute. And then we use E to denote the event and sample space S. Keep in mind that event E is any subset of the sample space S. We're going to call P this function of probability if it satisfies three axioms. First of all, non-negative. As you can see here, that the probability of event E should be bounded between 0 and 1. It can be 0 and it can be 1, and it can be anything in between. Second axiom is the total should be 1. And in our notation here, because total is the sample space which includes all possible outcomes, so we are able to use P of S to be 1, and then that is total 1. Lastly, countable addition. So notice the notation here. We're looking at the probability of the union of all of the events here. And you can see that you can have infinite number of events. So we use EI, subscript I, to denote the event EI. And then we're union taking all of them. And when you have any EI and EJ to be disjoint, we're going to look at the definition in a minute, but it's really saying that there's no overlapping between any of the two events in all of the sets that you're looking at. Then the probability of union of all of the events will just be the sum of the probability of each of the event. And the disjoint events here, if you have k disjoint events, disjoint meaning that there are no overlapping between any of them. And then the probability of the union of the k disjoint events will just be the sum of the k probability of each of the events. Okay? So those are the three axioms of probabilities. They are super important to keep in mind, and the future material we cover in this semester is based on these three axioms of probabilities. And I want to also preview some of the simple propositions, and in class we're going to take time to prove them one by one. The first one is the complement rule. The notation here is that we are using A with the upscript C to represent the complement event of A. So the complement event, AC, probability of that should be 1 minus the probability of event A itself. So this is the complement rule. The difference rule here is that if we're looking at the intersection of event B and the complement event AC, then it will just be the probability of event B minus the probability of event A, if A is a subset of B. So notice this notation here. This is saying that A is a subset of B. And in class, we're going to prove this as well. Lastly, the inclusion-exclusion proposition here. If you have two events A and B, they are not necessarily disjoint, meaning that you can't have intersection between those two. Then the union event, A union B, the probability of that will be the probability of A plus probability of B minus the intersection of the two events, P and B. So this is the third important proposition we're going to prove in class as well. And we're going to also look at example in class.